Okay. So stage is mine first. I think I'm more excited than him. I prepared a little speech, just a little bit of it, and today actually it's really a great honor to have host Ron Tzur, one of the pioneers in mathematics education research, and in almost a quarter of a century, I think, he has his work mainly focused on nurturing and promoting students' reasoning multiplicatively, and also the teaching of elementary and upper elementary teachers, their teachers for promoting their students' reasoning multiplicatively, multiplicatively and in fractional reasoning. Yeah. And out of this expertise, he will give a talk on a framework about teacher perspectives, explicating the teacher's perspectives that underlie their practices. And this work actually was very influential, and it influenced us a lot too. And we have conducted a research with NSF Foundation here in Turkey, and we worked on the development of a PIP perspective, progressive incorporation perspective, on the part of prospective secondary mathematics teachers. And it will be a great honor and privilege to listen to Dr. Ron Tzur today further on this issue. And now I take the stage, leave the stage to him, and I thank him for being here with us and giving the talk. Thank you.
Well, teşekkür ederim. That's the only word I would probably remember in Turkish. I know a little more. And I want to thank Boğaziçi and Zelha for the opportunity to come here, first and foremost, to do some work together. And then, of course, also present some of and share with you some of the research I've been doing more than 25, nearly 30 now, years. I also want to thank, before we start, the two people that really I worked with and with whom the whole thing came out. One is Marty Simon, who was professor of Boğaziçi at Penn State, and he's now in New York. We worked together many years, became very close friends, and I still learn from him every day. I'm serious about it. Everything I read that he does, every piece of research that we do together, he's serving on a lot of my advisory board projects and so on. The other one is my doctoral student, now Dr. Jin, whose research in China that I had the privilege and honor to join was leading into the progressive incorporation perspective. And then I can thank Boğaziçi again for actually picking it up and moving with it. I have not had time in the last 10, 15 years to focus on those perspectives regularly. It is only now in the last project that we had from NSF that we're really working on it again. But you took it further, so if I miss anything, the students should tell you, and then you tell me. Here's what I plan to do today. I hope that you can read it. I realize that the colors sometimes, especially the blue, is not appearing, but the white should be fine. I'll give a little, let me go back and make an introduction, because at the end there will be questions and answers, and one question that could come up at the end is, so how do you help teachers move from one perspective to the other? That's not what I will talk about. I will talk about, when Marty and I started the work, we started like, there is nothing about how teachers develop. So first put something on the map, and then talk about how they may go from one to the other. That's a whole different issue that requires more time, but unless you understand the developmental progression, how do you explain how they move from one to the other? So we focus today on those perspectives. I'll try for each one to provide an example and somehow what the essence is. We'll go through those. And as you can tell, the order as it will be presented is not the developmental order. Progressive incorporation should come before conception-based. You can hear me without the microphone, right? Is that okay? That's usually the case. I can have like a whole 2,000 more people that would still hear me. You don't want to be my students in the class because they think I'm shouting. And then I'll present a short discussion of the main things that I think are important for us as math teacher educators, and there will be time for questions and answers. At any given moment, I love interactive sessions. If you have any question, or if I talk too fast and you want to tell me, Ron, slow down, or if you want to translate something into Turkish because it's really important, and just by all means, don't be too polite, and then the learning is the most important thing, and support it in any possible way. So I'll talk a little bit about, just one slide, about why are we doing the thing. The most important thing that Marty and I came up with, which is coming out of constructivist perspective about students. We say that when students do certain things in mathematics, when they multiply instead of add, or they think that 1/5 is smaller than 1/7, and they have a reason to do what they do. And we suggested that the same approach should be applied to teachers. Why are they doing what they're doing? That's basically what we're trying to understand. And so the underlying assumption when we work with any human being, and specifically with teachers here, what they do makes sense for them. They may not understand the math and make mathematical mistakes. They may not understand the students and refer to something else. You may have critical eye on what they do, but for them it makes sense. And if we can understand it, we are better off explaining and working with them and helping them grow. And that's basically the assumption. And then our goal is, of course, is to distinguish what we're going to try to do here, some key aspects of why it makes sense for the teacher. Why are they doing so? We will look into those things that explain it. Marty and I realized that you can do a lot of things, and just a lot of work in the field, teacher beliefs, tons of stuff. And we said we wanted to focus, because we come from a constructivist perspective, on how the teachers understand learning. If you think about it, all of us, when we go to the class, we believe our students should learn. They don't know this concept, we want them to know this concept, and we do something for them to get this concept, and then we move on. So, two things. If I'm a carpenter, in order to build a cabinet, I need to know something about wood, about nails, about glue, about hammers. I need to have some knowledge about my stuff. Teachers have knowledge about what does it mean to know mathematics, and how does someone come to know it from not knowing. And so we took the focus, the lens of explaining why teachers do what they do. Obviously, an administrator would say they do what I told them, or they don't, and there are different lenses to put on what teachers do. We decided that we will put the one that makes them professionals. Understanding the material, this is why I bring the carpenter example, material that makes up their profession. What people know, how they get to know. That's what they're there every day to promote. And the methodology we have been developing, some of you probably read about the account of practice methodology. When it says I, it is basically interview. You basically interview the teacher before the first lesson you observe. Then you go and observe the lesson, you document it on video. Then you interview about what we have just seen, and what is the result of this we will see tomorrow. So you have 2 consecutive lessons that tells you what the teacher is thinking about what they're doing, and then you go into the lesson, you observe it again, and then you interview them about the second lesson, both lessons, and then what they're going to do tomorrow. The most important part of the whole thing is here between the interview and observe, because you get to see, you now know what they did on the first day, so you have some idea of what the teacher was doing, and then you ask them a lot of questions, and then you see how the teacher links what the kids had on the previous day to what it is on the next day. And that's where we really look into the learning that is taking place. When I started working with Dr. Jin, she said that was the thing that immediately brought her into it. That there's a serious attempt to understand how the teacher thinks from one lesson to the next. It's not just, before that, most people either went out and did interviews with teachers, or went out and did observations. We took both and created a very solid way of collecting the data so we can tell on our mind why the teachers are doing what they're doing. Let's just start with, how much time do we have until what? Until like about...
4 or 5 minutes. Like,
okay.
they said that's
If that includes the questions now, or?
You can, they said that you can stay a little bit later, you know. Just
Yeah, I can lecture for 2 days now. Right. So I wanted to give an overview of what we're doing. We're saying there are 4 perspectives, that's on the left side, your side. And then on the top you see the 3 categories we're organizing those perspectives by. The first one is, what does a person think of math? Where is math in the world? If I told you the number 5, where is it in the world? Complex number, let's say 5 plus I, whatever it is. Where is it? What do you think in the world it is? Teachers have a view of math. And they understand where it is, and it impacts what they think they are doing with their students. The second column is a result thinking where math is. Also, what do you think will help the students learn? How do they get from not knowing to knowing? The third is something that is pretty clear. Based on these 2, what do you think you need to do as a teacher for the learning to happen? So this seems to be a pretty straightforward thing. It is going to be a little more complex as we go into it. The first one that I'm going to focus on here, without many examples, because you all have examples either from your life as students or from your own teaching, because you might have been in that place. Most of us grew through it. Traditional perspective is very simple. If you want to describe teaching to the traditional perspective, that's what I do right now. You just stand there and transmit knowledge to the others, and you believe that when they take notes, they are actually listening to you, and they take notes not about what they're going to do to buy in a grocery store. That's what it is. What we suggest, analyzing it a little further, is that math is a connected, logical, universally accessible, independent of the knower body of knowledge. It's out there. It doesn't depend on anyone who has to learn anything. It's just there. And it's all connected, and it's really logical. Later on, I would say, for someone who knows. And from that perspective, what the students do, which is in error, does not make sense. It makes sense to the student, but not from this perspective. So from that perspective, when students come and they don't know, you have to fix their lack of knowledge. The knowledge is there. They need to get it. The learning, in a traditional perspective, is coming through very passive reception of things. You sit, you take notes, you do homework, and then you go to test, and then you know. And practice makes perfect is probably one of those things that everybody around the world is saying. That's what you do. Practice, practice, practice. You hear the lecture, and then you go home and you do 20,000 exercises, and then you get it. And the teaching is, of course, lecturing, presenting, transmitting. You're basically an instructor who instructs your student. Does that make sense? Any questions so far? So we're going to start moving away from traditional. And the first thrust for Marty and me to do this work was the reform in the United States, the NCTM standards. They all talked about we need to change that, and we said, well, how are teachers changing? We realized that there's more to that. So we're going to look into some pictures from a teacher in China. I was in China last year in the spring and did my sabbatical over there. And we worked with 2 teachers. This is Lily, the other one was Yong. She was a 6th grade teacher. He was a 4th grade teacher. And we did an kind of practice with them. Interview, observation, interview, observation, interview. the second one that I'll bring up would be how I taught Young's class, fourth graders fraction. That is coming up. So these are some pictures, and I hope they appear kind of. I'll point out what they're doing. So you can tell that initially, this is her geometry lesson. They're working on the connection or inverse relationship between they use papers and they roll them into cylinders, and they try to figure out the relationship between the radius and the height of the cylinder. And I shared with it last night. It's really interesting because the progressive incorporation perspective came out of China. They are now having a national curriculum that seems to move them in the developmental thing back into perception-based. So they do all, and they take it from the United States and Australia and other places where they do things. So you see the kids first take time to build 5 different cylinders. Then it's hard to see, but the kids here are holding, this one is holding something really long and thin, this one is really wide and short, and all the kids come and present what they build. So first they build, let's go and do it. So you have hands-on experience of actually building those things. And she goes around and you can see that she's asking them questions and they are working together in groups and so on. They are measuring and documenting the measures on a table that they create that the teacher provided them. So the teacher already organized all the data. They're not working to organize the data. And I'm pointing that out because you can see the person who organizes data has the knowledge what to look for. The kids don't. And the question is, why would they ever believe that or come to that, which is a major issue. It reminds me that I need to make a comment earlier about traditional. Traditional was great, except for it never worked. What people found, the reason they moved to reform in the United States and around the world is because they realized that just by trying to transmit to someone else my knowledge does not mean they get anything. And they started in tests, they started in problem solving, they started transfer was not working, you give them problems, they can solve this. You take them a little to the right or to the left, whoops. Kids have no idea what to do. And overall, it was a big failure. And we would show why, conceptually, that is expected to be a failure. Basically, the students who actually got the math, I grew up in a system that uses traditional perspective. How did I get the math? Not in a class, not in a school. Oh, my head, I read other things or whatever. Those who survived the system of traditional actually went over. But most kids, 85, 90%, not get it. They may fall at the move from additive to multiplicative, or to fractions, or to variable, or to function, or to complex numbers. Someplace that method stops working for them. And there's a reason why it stops working quite early on for most of them. So what you see here, it's a little difficult. You can see that now they come to the board. That's the third part of the lesson. And they're presenting their cylinders, and then they write on their board all the measures in a table that was prepared there. And if there were some errors in measuring, the teacher would bring it up, because there is a pattern here. There's a mathematical pattern that she wants them to realize, not just the decrease, increase, but actually what is the quantitative relationship between the diameter or radius and the height of the cylinder. At the last part of this perception, and you would see that quite often, there is some kind of a summary. So the teacher brings up the things that you hoped for the kids to see. You're creating hands-on experiences for the kids to see the mathematics you see. Try to point out. Let me make an example. I want to point you all to a place on the wall. You don't yet know what I'm looking at, but can you see number 6 on the right side corner? Okay. Can you go along the number 6 all the way to the top of the screen where you can still see some bluish thing, the black and the white, and then you go to the right about 1 meter, do you see a little ankle in the wall? The golden thing that goes into the wall? That's what I wanted you to see. The same thing is working here, kind of a simplistic way of thinking about it. I want my students to see something in math. I walk them through things and experiences that open the seeing for them. I see it. If we'll go through all this, they will also see it. The most important thing for the teachers in perception-based perspective, we call it PBP, but I'll try to return to the name, the real name, is that the students not just get the math, they also understand. So they call it seeing, which includes both. They can understand what's going on. The interesting thing is the view is the same as what math is the same as tradition. There's no epistemological change about the nature of knowing. It's out there, it's interconnected, it's logical, but for learning, because I can see it as the teacher, I can help them also see it through the hands-on experiences. And to foster that understanding, that's basically what I was doing. I juxtaposed the number with the end of this, with the line on the wall. Now you see it. We put together experiences. All of those hands-on experiences have a purpose from the teacher's point of view. The teacher may not be aware of it. We are making that inference. But it makes sense that that's what's leading what the teacher is doing. The teacher is trying to say, hey, do you see this? Now can you do with this, can you see this? With this, can you see this? So think about those kids. Do you see that if you use the same piece of paper and you roll it thinly, it will be long, but it will be really tiny radius. And if you did the other way around, it would be large radius and so on. Do you see that? Yeah, there's a difference in the shape. Do you see that actually you have different numbers? Yes, we do. Do you see that the numbers are related to those shapes? You see how we build a connection to the previous thing by having the hands-on experience leading into the idea we wanted to see. That's basically the way it is working. And eventually it leads to an algorithm. So if I do the long division algorithm, and I write a problem on the board, 308 divided by, I don't know what you do in Turkey, in some places in the world they do it this way and some this way. But think of long division, 308 divided by 7. 7 does not go into 3. So then we have 7 go into 30, and it goes 4 times, and I multiply it. So all of this for a teacher in a perception-based perspective has a meaning. The reason we could not do 7 into 30 is because we cannot put it into 3. We cannot take 3 units of 100 and equally divide them into 7 groups. We have 3, 1 and 1 and 1. Oops, 4 would not get anything. So we changed the 300s. I'm talking to you the way teachers talk to us. I take the 300s into 30 tens. Now I can't put some tens into those 7 groups. I'll put 4 in each group. I basically distributed all the 28 groups, and I have 2 groups of 10 left. Now I have to do something with those 2 groups. I cannot put them because it will not be equal. I break them into ones. All this process that makes sense turns into an algorithm. Algorithms are the result of sense-making processes. And for us, the issue is that the nature of this knowing did not change from tradition. What did change is how they have to come to see it. They cannot just hear it passively. They really have to work hard and get the experience in order to make those connections. So eventually, the algorithms make sense. Why is it sensible for teachers? Which, when we'll get to progressive incorporation and conception, it would sound, well, from some perspective, it is not at all. But from a teacher's perspective, and most people in the world who moved from traditional, let me make a guess, I don't know Well, I do know two people. Now I got to know some people that know Thompson and Ellen. And so, hey. So now I know more people. But I don't know you as teachers. I've never been to your class. I suppose most of you, at least at some point, and maybe for quite some time, teach as a perception-based perspective. You really are tired of traditional, and you're trying to engage your students in some meaningful experiences, hands-on, so they will see what you see. We'll talk why that doesn't work, but why does it make sense? All of us, humans, naturally assume the world that we live in is also the world others live in. And so what we can see, hear, smell, whatever, others too. It makes sense. If we will go out and there will be some stairs to go upstairs, I assume everybody would go upstairs. They would not jump into the Bosphorus just for the sake of taking a bath or something. They will just go upstairs because that's where we'll go for lunch, right?
Yeah.
Turkish food here. So the world makes sense to all of us the same way. There's no reason for me to believe that Zelha cannot see what I see. But she may not yet see it, so my role as a teacher is to help her get it. And so the apprehension is of the reality is independent of what you do. You just need to come to see it, but there's no epistemological standard. Reality depends on you. You do not see it or you come to see it, but it does not depend on you. The stairs are there. You remember the old logical fallacy of if a tree falls in the forest and nobody is there, does it make a sound? That's the issue. The tree is there. Assuming that there is sound is only that there is a hearer to hear it. But for that to happen, you need to have the hearer bringing in something. And consequently, and the notion of mathematical truth. So math is out there. We just need to work with them to bring it up. So in the table, we can now add, and you can see, and I'm serious about it, I copied and pasted what's in the first one to the second one. There is no epistemological change of the nature of knowing between traditional and perceptionist. They are absolutely having the same view of what math is. What they really differ, and what makes learning for students so much better, they have much better chance at it, is the activity and the hands-on experience, because we know that learning is active, and there is a discovery via the active, direct perception of the relations of the mathematics, or whatever it is I wanted to learn. So the place where change came from traditional to perception-based perspective is in the view of learning, not in the view of what students actually eventually get to know. That's the same thing in both. That's where things are going to change for the next two. And, well, we've seen it already, and we know what perception-based teachers do. They basically try to explain, point out, engage you in hands-on experiences and so on. It's all over the world, reform-oriented teaching. That's what it is. What do we reform? We reform the traditional, and we basically reform that the kids are not passive. They have to be actively gaining the knowledge. I'm okay taking notes and taking pictures, there's no problem. But I think I sent you the presentations and you will be able to put it up, right?
Sure.
So whatever works for you for the memory, I go to conferences and do that regularly, so I have it in my pocket. But we are going to share it with everybody. So, interestingly enough, I'm following now the historical sequence of how the whole thing developed, and to explain what progressive incorporation is, and some of you are engaging working on it, it's better to understand what it is now. So we will distinguish it from conception-based perspective. So I'll give you an example of a classroom that I taught, now it's a year ago, in classroom on fractions to 45 Chinese kids. Now, I don't speak Chinese. I have a few more words than in Turkish, but I don't speak Chinese, so we had people translating and so on. And I already worked with those kids. These are the fourth graders, Young's class. I already worked with them for a whole week doing the French fry activity. Some of you, if you have not seen it, you probably want to go and find this article and use it for your kids because it is so much fun. Besides the fact that it teaches fractions in a way that, let me say here, because we're not taught, fractions are not parts of wholes. If that's the way you thought, they are not. Mathematically, they're not. And learning to part of a whole is the number one enemy of kids learning fractions. I'll say it again. You can see the face there. Fractions are not part of a whole. That's what I was working with those kids for a whole week. They are something else. I'm not going to go into that because that would require working with Steffi for about 16 years or something. And in order for you to let go of that idea, which is how teachers around the world, Singapore, the best in the world, that's what they teach. China, that's what they teach. They are something else, and if you teach as part of a whole, which is mathematically wrong, think of 5/4. Is this a fraction? How could it, by language, be part of a whole? It's larger than the whole. How could it be part? You have to have some other way of talking about it. We published a lot. Marty just had a few articles out in JMB. I think we're still impressed. But we published a lot of them. The French fry activity is what I'm going to do, and I did it with the kids. 45 kids in the class, let's engage. They take pieces of paper, they do this, do that, all week. We believe they got some of this new understanding of what we call multiplicative relation. So 1/4 will be 1/4, not because it's 1 out of 4 parts. So let's give an example so you just get it. Gulsarian had $2 in her pocket. I have $8 in my bank account. Could you tell what fraction is Gulsarian's $2 from my $8? You should say it's 1/4. Notice it's not part of, she never wanted to give it to me, so it's not part of my 8. And it's not anywhere near it. It's totally independent thing. What makes it 1/4 is very simple. 8 is 4 times as much as 2. Say 2 as the French people would say. Another way of thinking about 2 fits 4 times into it. Why is 5 minutes? Where's the clock? 5 minutes, 1/12 of an hour. Not because it's on this circle. No, it's just because of take a piece of cloth that is 1/7 of something and send it to the moon. And get another piece of cloth that is 3/7 of the same thing and give it to someone in Australia. And what the piece on the moon is of those 3/7 is 1/3, and it's not going to change because 3 times as much as 1 is 3, and this is 1/3. So multiplicative relation is what we need to teach, and that's what I'm working with those kids in the 4th grade to learn through the French fry activity. We have a whole thing that does it. That's again another talk. And we feel they got it. So on the next lesson, we're saying, from a conception-based perspective, we probably could use their knowledge of unit fractions to start developing non-unit fractions. 3/7 is a non-unit fraction. Unit are all those 1 over, that's what we talk about unit fractions. Non-unit fractions, everything else. 5/4, non-unit fraction. 3/7, non-unit fraction. Let's say 110%, I just got from the bank. I wish they did. So all of these numbers are non-unit fractions in the sense that some unit was multiplied something. 3/7, we took 7th 3 times. 5/4, we took 4th 5 times. 1 and 1/4, we took the 4th 5 times and then we organized it into the unit of 1 and another whatever it is. That's basically what we're heading into the class. But I also had some conversations with the teachers and we analyzed data and saying, something is not working, I can feel it. 2 minutes, so we have a whole plan. I'm starting the plan by getting them to do some of the stuff. I'm going 2 minutes into the lesson and I realize, my goodness, they're not with me. They're not. And a conception-based perspective comes from, in order for them to learn anything I hope for them to learn today, I better start with what they do have and build off it. And if they don't have it, what am I going to do? what I realized that they were taught, not exactly part of a whole. That's not the main way of thinking about fractions is the teaching in China. And I now have a very clear sense that this is what they're doing also in their thinking. They were taught that a fraction is the result of division. Let's now talk mathematically for a second and then pedagogically. Anytime you divide something, the result could be thought of as a fraction. But not every fraction is a result of division. I can think of a lot of things that are fractions that have nothing to do with division. Yeah, you can present it that way, but they don't have to be the result of it. You can make it look like it. So mathematically, it's the difference between necessary and sufficient. Everything that was divided could be thought of as a fraction. That's true, a rational number. I'm not making clear distinctions here. I'm not thinking of them as symbols. But not everything, and this might be 1/100th. Well, if I bought 100 of those, yes. If it costs $20, yeah, 2,000 will make it. So everything, and there was nothing divided. This mite was not divided into anything. Nothing else was divided. It can still be 100 or something. So the idea, what we now have to do is work from where they are with division to unit fraction is a multiplicative relation. It's not the same. They are related. Without a division is a multiplicative relation. But if you don't have to be like that, then what we do is I'm saying, okay, let's take, I'm saying, where are they? Can they understand division? Yes, here's a whole. Use Java bars. Those of you who might have seen it. Here's a whole, 5 parts. Pull out one of them. What is it? 1/5. How do you know? Because it was divided into equal parts. We have the whole discussion. Perfect. I'm bringing in what they know with the goal of changing it. They change it, but I cannot change it. I cannot tell them how to change it. I've done it the whole week and it didn't work. I'm not going to believe myself. I'm not going to deceive myself. So we do this. We have the discussion. Everybody is with me because that's the knowledge. And then I create a perturbation in quote unquote. It is not a perturbation for them because they still think division is what created. I remove 4 of the parts and leave only the one that they just said was 1/5. So now it's still 1/5 because it is the result of division, although you cannot see the whole anymore. Everybody is with me? And then I create a perturbation, which is what Piaget and Philosophy taught us that we need to do. In order for learning to happen, they need to see something they cannot solve this with. So I'm bringing another.
Can you explain maybe that's an important part?
So I'll just bring 9th and then, yeah. So I'm bringing in the 1/9. I'm just bringing in, here's the whole. They see the hole in the screen. The whole class is looking at the screen like this with a hole that was made into the 5/8. I say, did you see me partitioning it and dividing it? No, they don't. I bring just a little piece and I say, can you tell me what fraction of the whole it is? And they said they can't. But then, because we worked for a whole week, I started seeing kids doing this. What they are now bringing in what they learned earlier was if you can iterate the unit, define how many times it fits in the whole, you'll figure out what fraction it is. Once you took away the perturbation, take away anything they had to develop, but they can still understand what the task is. They did it with a 1/5, they're now asked about another one. What is it? And so once they do that, we repeat it several times, and we discuss why was it working, how is it different than the result of division, and so on and so forth. Yeah, let me stop, and whatever it is that you believe needs to be explained. Zelha, it's yours. Take it. Explain it.
Okay,
And you can do it in Turkish. I understand a lot.
Okay, the 2 perturbations. The first one, you have these 5 pigs and you erase 4 of them. And what is the question that you're asking?
What fraction is the piece that was remaining, which I already decided was 1/5? How do you know it is 1/5?
Okay, they don't say.
They don't have 5 parts, so they cannot anymore talk about 1 out of 5 equal parts.
Okay.
But it is still the result of that division.
Yeah, and they were fine with that, so
Yeah,
that's not a
absolutely.
perturbation.
This
That's
is why I
okay.
call it, it's not a perturbation in full sense of they don't know what to do with it.
Okay. And the next one, is it related to the previous perturbation, quote unquote? The next one, need.
Yeah, so I just bring another piece. It is 1/9 I created in the
They
dream.
have to reverse their thing.
And now they have to say what is it out of the whole without any partitioning or division happening. I'm trying to help them understand that what determines what a unit fraction is not the action that was done to the whole, but rather the relationship that exists between the whole and the part. That's a huge shift in learning fractions. Trust me, I work with teachers, it's huge. I work with kids, it's huge. It was not that hard in China because they were not taught part of a whole. If you get people who were studying fractions as part of a whole, that's huge. Huge. But it is easier here. It's still a leap. So they have to make that change by having that perturbation and repeating some of this, and we have a game for it.
So it wasn't a perturbation for them then.
Hmm?
They were fine, they were able to understand, they had some
The task.
perturbations over it,
Yeah, the task was understood, so we created perturbation. But they didn't have an available way of solving the problem. They had to work on it. And that's what they brought in. Yeah. And if they wouldn't, I might
At
go
that
back
point,
to
that
this
would
one.
be perturbation, in my view. Okay.
Go ahead.
And did this help you reach your initial plan or aim?
So,
Creating non-unit
yes, but indirectly. What it helped me do is make sure that when they operate on a unit fraction, they are now multiplicative relations. So if they take a 1/9 and take 5 of those, 5/9 now makes sense. Before that, it did not make any sense except for the algorithm. Now it does make sense because it is something that I can take 1/9, I can take 2 of them, I can take 5 of them. I can also take 10 of them.
What if you show them 2 9s and without partitioning the whole and not really offer the unit fraction?
So part of it would be that they would have to figure out what the 9th was before they can say 2 of them. So they can see 2. If they don't know and nobody tells them what the 9th is, this is why I went all the way down to reestablish what the unit fraction is, so you can see how many there are. And that goes also from the research we were doing in fractions, from a much higher level scheme, which we call the reversible scheme. When you see a non-unit fraction, can you recreate the whole? You have to first divide it by 2 9ths, you have to divide it by 2 to make 1, and then take 9 of them.
Because I wondered whether they
That-
went to 1 4.5.
Yeah, but that would be a much higher level understanding, especially if you don't have the unit fraction established. You need to know what you are shooting for. So, yes, and later on, of course, we could go with non-unit fractions much better, and now they understand that they can operate. So I reached my goal, but the question is right on the mark. As a teacher, if my goal today was non-unit fraction, at the end of this lesson, they did not have non-unit fractions. That goes to what conception-based perspective is. Where the students are determines the goals you can set for them and how you get with them to those goals. So it might be that in specific lessons I don't get it. My willingness to live with it and the flexibility actually allows the teachers that we work with right now. I somehow at some point apparently said it because they quote me on it, but they're using it quite regularly. I have to, if unit fractions are really foundational, it's like number or like whatever it is that is foundational, I need to spend time on it. So we are purposely going slow on the foundational, and then we get much faster on the thing we need to teach. All the algorithm and other things that come up later, so if they need to compare unit fractions, they would never make mistakes. 1/5 is always larger than 1/7. There's no question for them. It comes through those activities.
I had a question. This is huge for them, like coming to know non-unit fractions is because they need to think about unit of units. Unit of units, right? I mean, unit of units.
So not here. That will come up if I took 1/2 of 1/9, what is it of the whole? That will be unit of units of the unit.
Okay.
But here you just need to relate one unit to another. It's still a unit perspective, but it is the relationship between the two units is how many times they fit one another.
Much more additive still, they can figure out that additive thinking is enough for them to get to 9 nines.
I don't think so. Well,
With their operations.
all right.
Copy.
okay, let me be now, I'm going to use Les Steffi, and if I said anything that you don't understand, ask Selma. She's a student, so she knows. The work that we did, Les and John and I and Barry and Ivy and all the team in Georgia, one of the things we learned was that when a child has number as a composite unit, the partitioning and iteration of the one is available because of what they have. So conception-based perspective, do they have number as a composite unit? Yes, that is available. Going back to 2 9, until they have multiplicative reasoning, no. Can they do repeated addition, 1 9 and another 1 9 and another? Yes, they can. They don't understand 3 9 or 4 9 or 7 9 or whatever as a multiplicative thing. They just understand as a result of it. So as soon as you move from the unit fractions to everything north of it, starting with just 2 of the same units, you need multiplicative operations to actually operate on. Because you have 2 relationships. The 1/9 is 1 to 9 with the whole, and the 2/9 is 1 to 2 with the 9th. So you need to have both, and it's tough enough to have it even if you have multiplicative relation. I just don't believe it is possible. When it comes to 1/2 of 1/9, we call it recursive partitioning. Everything that goes into adding and subtracting unlike denominators, making common denominators, everything that you teach in fractions, that the teachers teach in school with perception-based and experiences would not work because they need to have that operation. I need to understand, if I take 1/2 of every 1/9, I would have 18 of those. Each of them is 1 to 18 with the whole, so that's 118. And how many do I have? But you have to have that. That requires units of units of units. It's much higher level. Let's move along to this. So the view of math in this, in conception-based perspective, is dynamic. It does not depend just on the learner, but it depends on the learner as well. What the learner brings to the situation determines, affords and constraints what they can see, what they can do, and how they can think. So learning is a conceptual reorganization. Take what they have and you massage it, and suddenly it's something else. You can't just give knowledge to anyone. They have, now I want to be really careful with the language because I think that it is around the world a serious issue with what people say about constructivism that none of us would ever say. Constructivism is a sense of, in order for someone to learn, they have to take what they know and construct for themselves what you want them to know. But they don't have to construct it by themselves. No one that I know of would say that kids should construct knowledge on their own, which is one of the issues with the perception-based perspective. If you just well engage them in all those activities, they'll come to see. Well, what I just told you about the fraction, I worked with them for 1 week, and they did not come to see it. And I have to be ready for that idea that it's not about what I have and what I thought and what I saw, but about what they see. And so the change in the thinking requires that they bring what they know. You can't just add to it as much as you want. Because they have it, you can build off it and give something else. You cannot give knowledge to anyone. That's a crucial statement for teaching. So the teaching changes, of course. Teacher basically has 2 camps, major camps. Engagement in activities, which is what perception-based perspective do. And then orient reflection on their activity based on what they are doing, based on what they know. You saw all the process I described. Okay, here's a 5/5. Here's just 1/5. They know how to do it. Now here's another one. Work on it. Let's talk about what happened here and so on. So that's the kind of in a nutshell what we did. I'll go quickly through all 3. So the nature of knowledge, you can see, it's very different than what the first two are. And it depends on what the person knows. A single person is basically what they know a lot. And now we know from brain research, by the way, people physically see things only that their brain allows them to see. When they don't have something in the brain, they can't see it. The brain does not register. There's no brain activity in the sight center for things you don't have something to see with. It means that kids in your classes can only see things not because you pointed them out, not because you did any experience, but because they have concepts in them that allow them to see. And you have to take those into consideration if you want to teach them well. I assume you all read about the PIP, the Progressive Incorporation. I'll go quickly through it. The most important thing and why it came to being, and then we'll stop here and have questions. Why it came to being is because we saw a teacher, a 7th grade teacher, who started with reviewing what happened yesterday. And then his goal is to identify things such as what is b over 2x, how does it go into by over 2xy, or later on they would do x squared minus 9 over minus 2y squared plus 6y. How can you simplify? So you would have to do y minus 3 times y plus 3, identify there is a y plus 3 on the, all of this stuff. Now, he goes here, and he asks them to do things that they did at 4th grade. He knows that. Simplified, just common, easy fractions. And he builds the whole lesson on that idea that they know how to do what they call fanfa in Chinese. They take the method that was used for the old knowledge and kind of apply it to more and more sophisticated objects. So in constructivist perspective, you would say they're trying to get the same operations or mental processes applied to more and more complex objects, units. And we ask ourselves, why does he do that? Long story short, and when we came into this study, Jane and I, Dr. Jean, we had no idea. I actually thought the 3 perspectives, traditional, perception, and conception, are those that we have to work with. We're trying to push it here, it doesn't work. We're trying to push it here, no, they're not there yet, because they don't explain where it is. We have to come up with a different way of explaining it. And the view of knowledge here is dialectical, which is kind of coming from the old Vygotsky and actually it's Marx and Hegel stuff with the dialect in terms of it's this and that. Some of the knowledge is out there. Some of the knowledge depends on the learner. And it's only when you put them together and you can tell what the teacher would do, they have to put those things that it will bring in the bridging, those 4 common fractions, allow the student to bring what they do know. And the teacher is then working with it gradually to incorporate more and more sophisticated understanding. And they build a lot on the fanfa, that method that the child understands that the child can do on her or his own to bring the new one that they cannot. Obviously, if they did, there's no need for the teacher. They can go to Hawaii and sit on the beach. Quick 2 points and then questions and comments. Progressive incorporation that we developed over that with a thing in China suggests a way to engage and help all students. If you go at 7th grade for something that everybody learn and understand, and you have to know that they do, and the Chinese teachers with 50 kids in the class, they know who has what, then you have a better chance of everybody learning. When he went to 4th grade math, he did not hurt any upper level kid. He helped everybody, but he allowed everyone to grow, and they have a very clear system of how to help everybody at their levels. So this is an equity issue to a large extent. If you go back long enough in the child's history of math, they have more chances of getting what they want to teach. The other one, which is what Tzur did more than I did, thank you very much, is it seems to be a much more feasible goal for teachers learning when they are perception or traditional. Conception-based perspective, the idea that knowledge is not out there, but it is depending on each one of us, what we have here in this box. What we see is different. And as a result, every time I try to show something to my students, they don't see it, I assume they have the mental apparatus to see it, and they don't. So that is huge change in teachers' understanding of knowing and learning. It's much easier to have some combination, and it allows the teachers to see that, and I would open it up here.
Thank you.
Any questions? Are there more questions?
Why should we care about this? Why should we care about this? You already talked about it, but I think we need to read up and listen more. Why should we care about this change?
Thank you for the question, because I should have said it at the beginning, and I was too excited to get into the thing. Thank you for asking. Traditional perspective lead most of the students not knowing. Perception-based perspective gives a much larger proportion of our students a chance, not because the teacher knows what she or he does, but because the kids have a part of the activity that allows them possibly to get to learn and reflect on what they do, a better chance. Conception-based gives all the kids an opportunity to learn at any given moment because you really tailor, you are targeting the opposite. So every child learns. Not every child learns the same. The fact that they're all in grade 7 does not suggest they all need to learn or can learn the same math. Some should learn what is taught in 11, some should learn what is taught in 4, whatever it is. But each one of them is learning. In a progressive incorporation, if you can help teachers move from just traditional perception to progressive incorporation, they start considering where their students are. They give way more chance for their students just by doing that. So even if they don't yet have the full-blown conception-based understanding of knowledge as different, they give their students more chances. And now that I said all this, the short answer, because the higher you go in a perspective developmental pathway, the better your students are at math. To me, that's the answer that's the only answer that matters. I'm out in math education for the last 50 years, so when I was 12 when I started, so you can figure out how old I am. For the last 50 years of my work, I started very early on as a young child, is one thing: make sure that others around me learn the math. And these 4 allow you to really make a difference in the lives of so many more kids. To me, that's the answer. That is the thing that probably drives me in the world until I say, like, well, Steffi, well, I have enough, I'll be retired. I'm now talking from my heart. I think that all of us are there for a reason. Many of us, I could probably am one of those, came into education in math because of calling. We felt there's a calling for us to help others learn. We do it in math, other teachers do it in other areas. If everything I do makes no difference, I don't want to say that. I feel like, forgive me for the word, I feel like an idiot. Why would I go day in, day out to a class if I make no difference in the children's work? Now if we take it to the teachers, why would I work with teachers if they go back to their classes and do just the same? So to me, that's the reason. That's the underlying premise of the whole thing. The higher you are capable of bringing teachers on that mat, the better the students have a chance of learning math, and not just stopping at fractions, which is probably where most kids around the world stop. Thank you. There's nothing more important that I could say in this talk, and I forgot to say it up front. So the question everybody has in their mind. I'll bring it up. So how do you help teachers move from traditional to perception? We've been working now for 2 years with teachers in one school, very poor area of Denver. I'll tell you, it is tough. It is really hard. Just from traditional to perception, let alone to go maybe progressive. We got, out of our 20-some teachers, we got, I think, 2 or 3 that are starting to move into perception. Most of them moved away from traditional. But this is just like with children. You have to work with everybody where they are. But it is a very long process. This is why I'm not answering the question, how do you do that? Because it takes a long time. It's a whole bit, it's not just one lecture. But it is possible. That's the good news. Do you do this work more than I do? You do it with high school teachers, which is so much harder because they believe they know everything. And they need to learn so much more. High school teachers know everything. They know the math. I was like, I'm talking about. We know the math. We know the kids. We know it. No, we don't. No. So how to do that and how long it takes and what do you have to put in? That's where one of the things that I know that we are all in the same boat. In the United States, just like here, investment in teacher professional development. So maybe I'll culminate with a story, because I know that we have to go somewhere. I'll culminate, unless if there are more questions, I'll be more than open to it. But here's a story. A year ago, we're working with 2 districts. In the United States, there's some kind of a rule. It's not a real rule, but every 6-7 years, a district will change all the books. So the district we work with is one of the poorest in the Denver area and probably also in the country. They don't have a lot of money. They barely pay their teacher. They barely can make it. They fire a lot of teachers at the end of the week. Because we were in the middle, we had a professional development a whole year to work with the teachers with the curriculum they do use. Comes the summer, the district takes $70 million to buy a whole set of new curriculum. Our project takes about $1 million to work with 30 teachers. You make the math. 70 million is a huge amount if you invested in it instead of a new curriculum and a new way of thinking for the teachers. Work with them 2 or 3 years. If you really are interested in changing your teachers, professional development will take between 2 and 4 years. The fastest thing to do. And that's because they start at perception and maybe a little higher, you can get them really further. But people have different priorities all over the world. And investing in our teachers is not exactly what people think we need to do. And it makes me really angry when I think of what they do with the money, but I have no say in it. Zero saying in it. They just went and did it. They did not even ask us if the new curriculum is a good one or a bad one, which is relevant. But we're not part of the game. So just to get a sense of where we are, I think it's worth the investment. It is the best way of changing math education for the kids. The teachers are so much happier doing this stuff, but very few people. Well, thank you very much for coming.
Biz çok teşekkür ediyoruz. Bizden küçük bir hediye. Size little gift from us.
Thank you.
Çok thank you.
Thank you.
Ağzına sağlık. Teşekkür ederiz. Yes, and yes, we can take pictures now. They will probably love to go down there. Those are the students of us, secondary, prospective secondary mathematics teachers, and they are going to be great. They already graduated. 10 more days.
In China, everywhere I go, no matter what, as a tourist, they want pictures of me because I'm the only white person around. I'm taller. Everywhere they go. Right.
So, okay, so you have the energy now, right? Okay, that's good. Then,